Chapter 5, Section 1, Angles and their measure. So 5-1. Let's start off with this chart up here that obviously is wrong, but that's okay. Because that actually is quadrant 6, it says there, but it's supposed to be quadrant 4. Okay. We are going to start working with some angles here. There's two different ways to measure angles. One is in radians, and the other one is in degrees. Okay? There's two different ways to do this. Radians have to deal with pi. Degrees will deal with that little circle up there that has degrees on it. That says degrees. Okay? When we work on a circle, or when we work on a quadrant like this, we always start out at 0. No matter if we're talking about radians or degrees, we start at 0. And it's always in this right spot right here. Okay? As we move our way around, we get up to 90 degrees or pi over 2 radians. We work our way back down to this x-axis again, and we're at 180 degrees or pi. As we go down to the bottom of the y-axis, we're looking at 270 degrees or 3 pi over 2. And as we come back around, we've reached 360 degrees or 2 pi. Radians and degrees. You're going to be using them both. Depends on what you're doing. Some will be easier to work with degrees. Sometimes it's going to be easier to work with pi. Okay? Depends on what you're doing. Now, the same goes this way. If we go this direction here, back down, we're at a negative 90 degrees or a negative pi over 2. And as we work our way back up this way, we're at a negative again. Negative pi or a negative 180 degrees. Negative 270 degrees or a negative 3 pi over 2, and then back around. Why is it important to know that? Why is it important to know the negative sides of it as well as the positive? In case there's a negative number. Why else? Notice the direction. Notice the direction. Positive is always counterclockwise. Negative is clockwise. You will be working sometimes with a negative 45 degrees. Where's a negative 45 degrees? Which way? That would be a negative 45 degrees. Or a negative pi over 4. Okay? If we were looking at it from the positive side of it, we'd be coming around to what? 315 degrees? Or, what's 1 shy of that? 1/4 shy of it is 7/4 pi. What would be easier to work with? Would I want to work with 45 degrees, pi over 4, or 315 degrees, or 7/4 pi? Yeah, it's kind of easier to work with, like, when you look at that, right? So there's times that you're going to want to go, you're going to be using that direction and working off the negative side of this. All right? Now, the next thing we need to know is, where is the conversion for this? Because there is a conversion for going from pi to degrees, or radians to degrees, and going from degrees back to radians. Remember, if we wanted to go miles per hour, and we wanted to know how many feet per hour we went, there was a conversion for that, right? If I was doing, let's say, 5 miles per hour, or if I wrote it this way, 5 miles per hour, and I wanted that in feet, I would do something like this. I would multiply 5,280 feet by 1 mile. My miles would cancel out, and I'd be left with feet per hour. Remember doing that kind of stuff? It's the same thing we're going to be doing with radians and degrees. Let me go ahead and erase this. If I'm going to go from degrees to radians, okay, and we already know this. When we look at this, we know that this is 180 degrees and this is pi. All right? We're going to use that. So remember, I want to go 2 radians, and my radians are in the form of pi. Then I'm going to put my pi on top. So let's say I've got 45 degrees, and I want to figure out how many radians that is. I'm going to multiply this by, I'm going to put the pi on top, because that's what I want to go to, over 180 degrees. Now my degrees cancel out, and I'm left with pi. 45 divided by 180 comes out to what? 1/4 pi, or pi over 4. So if we looked at this right here, this is really pi over 4, or 45 degrees. Okay? If I want to go from radians to degrees, then what's my conversion going to look like? What's it going to look like? (180 over pi). 180 degrees over pi. Because I'm at radians and I want to go 2 degrees. All right? That's what you need to know of your conversions. Last thing I want to show you. Have you ever seen something like this? 36 degrees, 22 minutes, 14 seconds. Have you ever seen anything like this? What's that? This is the degrees here. But if I wanted to turn around and put this into a decimal, all right, I'm going to divide. How many minutes are there in an hour? 60. Divide that by 60. How many seconds are in an hour? 3,600. 60 times 60. An hour. Yeah. 60 seconds and 60 minutes in an hour. 3,600 seconds in an hour. Okay? I can turn this into a decimal. Let's take 22 divided by 60. 3.66. I'm going to say 3.67. So I'm going to go 36 plus, I'm going to add these together, 0.367 plus whatever this is, 14 divided by 3600 is 0.00388, so we'll say 0.00389. And if I add these up, let's go 36 plus 0.367 plus 0.00389, 36.371. 36.371 degrees. Okay. Can I convert that to radians now? Yeah. Now I can convert it to radians. All right, and I would do pi over 180 to be able to come up with radians. But this is your conversion. This is right here. This is degrees. This is minutes. And this is seconds. Okay? And that will help you to be able to do conversions back and forth. If I came up with a pi, if I wanted to go back the other way, what would I do? Well, I want to be able to figure out what my minutes and seconds are. Well, how did I come up with this? I divided this, right? So I'm going to multiply this times 60. All right, I'm going to come up with a remainder out there. I'm going to multiply that probably by 3,600. And I'm going to be able to bring it back into something that's, you're never going to get exact because we rounded. There's going to be rounding errors in here. But you should be able to come up with a minutes and seconds if you had to go backwards. I don't believe we do that. I don't believe you'll have to do that, but if you did, that's what you would do. All right? Any questions? Kind of easy. Kind of straightforward, isn't it? All right. Let's take a look at what we can do for an assignment then. Take a look at page 245. Let's do odds. The first, I'm going to do 25, 27, 29, 31. What you're going to have to do is just tell me what quadrant that's in. All right, is it in quadrant? And I didn't really show too much on your quadrants. So you do have the quadrants right here. Yeah, make it 4. All right, you got your quadrants. This is quadrant 1. This is quadrant 2. This is quadrant 3, and this is quadrant 4. Okay. Starting at 25. All right, odds, and then next one you are converting from degrees to radians. Do the odds there. The next section, that's 41 through 47 odds, is going from radians to degrees. I want you to do the odds, yes. Odds 25 through 47 right now. I want you to do 53, 55, 57, and 59 also. Yeah, so do all the odds 25 through 59, just don't do 49 and 51. Yeah, it shouldn't take you long to do this. I will definitely write it on the board. I will definitely write it on the board. Page 245. Odds. Oops. Odds. 25 through 59. skip 49 and 51.